A car starting from rest needs to reach a freeway speed of 30 meters per second before reaching the end of a 150-meter ramp. What acceleration must the car be capable of? What information is given? We know the velocity is 30 meters per second. Looks like the starting velocity. Oh, starting velocity is from rest. That's good news for shortcuts. So our ending velocity is 30 meters per second, and the distance we've traveled is 150 meters. The question is specifically asking what acceleration. So the unknown is the acceleration. The equation that we can use is the one without time, and we're using the shortcutted version of it, which really it's not a shortcut. It's still the final velocity squared equals the initial velocity squared plus 2a delta x, but the initial velocity is just 0. So 0 squared is 0. So we have final velocity squared equals 2ax, and then we're going to substitute in some numbers. 30 squared equals 2a times 150, and after doing some algebra magic, we get 3 meters per second squared. A runner starts from rest and reaches a speed of 10 meters per second in 5 seconds. How far has the runner traveled in this time? What given information do you have? Pause the video now and try it for yourself. Velocity, 10 meters per second. We're starting from rest, so we know the initial velocity is 0, so our final velocity is 10 meters per second, and the time is 5 seconds. How far has the runner traveled? That means the unknown, in this case, is x. The equation we can use is using the average velocity solved for x, and the average velocity is our ending velocity plus the initial velocity divided by 2. By substituting in all of that, we get x equals 5 times 5, which is 25 meters. Please do not forget your units. You will not get this last point. Even if you have the correct answer, if you have the absence of units, then it is meaningless. Then it's just a math problem. A car with an initial speed of 40 meters per second needs to make an emergency stop. If the car's braking acceleration is 8 meters per second squared, how far does the car travel? The given information, we have a velocity of 40 meters per second and an acceleration of 8 meters per second squared. But my smart students notice that this is not an initial velocity of 0. Instead, it's a final velocity. So, final velocity of 0 because we're coming to a stop. The initial velocity is not 0. It's 40 meters per second. If you take that equation and you rearrange it, and you flip the final velocity for the initial velocity, you'll see it's still the same exact relationship. It does not matter which side your velocity is. So you can have your initial velocity on the left side or your final velocity on the left side, either one. Don't believe me? Check the algebra on it. So here's a little note. Final velocity is 0, initial velocity is 40 because the object stops, but we can switch if one of them is 0 to make the problem easier. So how far does the car travel? So that means x. V squared equals 2ax, or shortcut because we're saying the final velocity is 0, but it's the initial velocity, right? And then substitute, plug in your numbers. 40 squared, 1600 equals 16 times x. Divide out 16 to solve for x, and you get x equals 100 meters. Is that reasonable? 100 meters. 1 meter is about 3 feet. It's 39 inches. So 300 feet, 40 meters per second. Yes, reasonable. On to 6. A person throws a ball downward with an initial speed of 10 meters per second from the top of a 15-meter tall building. How fast does the ball move upon striking the ground? So remember, in previous sections, we would say, oh, it's undergoing free fall because we dropped the ball from the top of a building, and then it just gets accelerated by 10 meters per second every second that goes by. But read the question. A person throws a ball. This time not dropping, but throwing with an additional speed of 10 meters per second. So the initial velocity is 10 meters per second, the distance is 15 meters, and our acceleration, which is not explicitly given to us, but because it's moving through air, we know our acceleration is 10 meters per second squared. V. Remember, object is in free fall. Remember, the definition of free fall is when only the force of gravity is acting on it. By it, I mean any object. We're looking for the final velocity, so we're going to use final velocity equals 2a delta x plus initial velocity. We have an initial velocity that we need to account for, so we're going to include that. So here we go. V squared equals 2 times 10 times 15 plus 100. V equals 20 meters per second. If you want to rework that problem, it's going to be this whole front part. This is if we dropped it. It'd be 2 times 10, 20 times 15. We're just leaving out this 100. So 20 times 15 and then square root of that. Much smaller. Example 7. How much time? When a basketball jumper jumps, they spend 0.8 seconds in the air. How high did they jump? Going to make this problem easier. If the player's in the air for 0.8 seconds, then the player spent 0.4 seconds going up and 0.4 seconds going down. Parabolic motion. So let's just find the distance the player fell from at the top of his jump where his speed was 0. Because remember, if we can ever find a speed that is equal to 0, it's going to make our equation easier. So that's what we're going to do. All right, so the given information here, we have the starting speed. Our initial velocity we said was going to equal 0 meters per second. I'm not going to write units because I have to tell you, writing with this pen is not all that enjoyable, so the less I have to do with it, the less cuts I have to make. All right, the initial speed is 0. Remember, this is what we're doing here. We're going, thanks for zooming in. It's going to be a parabolic motion, so he's going to go up and then he's going to come back down. And even if he comes straight back down, it's still the same thing. Not a true motion diagram, just showing the trajectory. It's going up for 0.4 seconds and coming down for 0.4 seconds. And on his way down, he is in free fall, so we know his acceleration is 10 meters per second squared. 10 meters per second squared. We're looking for the distance that we're going to have. Well, we also know the time that he spends in the air. Time is 0.4 seconds. I just said that. There we go. All right, the unknown here, it says, how high did they jump? So we are looking for our displacement. In this case, we're not using x. Because we're not going along the x-axis. Now we're going in the vertical axis. So we could easily use y, and that would be perfectly acceptable. I don't know what this mark is there. Sorry. The equation that we can use, we have time, and we have x. So it would be